Okay, so for question 13, given that x squared plus y squared equals to 5x plus y. So we can see here our equation here. Which category? Okay, is it the explicit, implicit, or parametric? So obviously it's not parametric, it's just involving xy. And then we can see our xy. Y is not expressed as a subject in terms of x. So this is our implicit differentiation. They say y dot dot. What dot dot means? Y double. Y double prime means second derivative. Okay, so you have to identify, you have to look at our symbol here. Y double dot here means d2y dx squared. So normally we should writing it completely like this, d2y dx squared, because y dot dot you cannot see is respect to x or respect to y. Okay, so y dot dot is second derivative at x equals to, so given a point, x equals to 5, y equals to 0. So this is the information they give us and ask us to find second derivative. So this question is testing us on implicit differentiation. So we start our implicit differentiation. This is our first term, x squared. Second term is y squared. So remember, if the operation is plus or minus, means it will be differentiate it separately, independent, one by one. Okay, only the function which is multiply or division, then when we differentiate it, we have to use our product rule for multiplication function, and we have to use quotient rule for that function in fraction, in rational form. Okay, so this one we have one term, second term equals to 5x, consider another term, third term, and then 4y. So we have four terms here. Differentiate it one by one. Differentiate one by one because they are separate by this operation, positive and positive. So differentiate x square, we get power darab ke depan, power tolak 1, and then this is our responding x, respect to x, so responding variable x, so finish, that will be alright. Then for y square, we will differentiate it like x. So power move to the front, power minus 1, but because this is variable of y, the way of implicit will be multiply with the factor of dy dx. Multiply in with the factor of dy dx, then equals to, for 5x, differentiate this 5x, so will give us a constant 5. Then differentiate 4y will give us a 4, but that will, because this is y term, so differentiate implicitly, we have dy dx. So what is our objective here? We are going to find out second derivative. So means that our equation here, we are going to differentiate it again. Okay, so we're going to differentiate it again, then only we can obtain our value of d2y dx squared second derivative. So we can see here we differentiate the first term. So when we move to our second term from our answer here, the variable is in product already. So this is our product rules. So differentiate constant, then differentiate one terms here, dy dx. So differentiate one by one, differentiate 2, we get differentiate 2x, we get 2. When we want to differentiate this part, product rule, because we have two functions together, which is 2y and dy dx. So we're going to set up our product rule, salin yang depan, differentiate yang belakang, salin yang belakang, differentiate yang depan. So differentiate yang belakang, when we have dy dx, we apply differentiation again, it will become d2y dx squared. So this is how we differentiate dy dx to become second derivative d2y dx squared. Then when we want to differentiate yang depan, 2y. So when you want to differentiate this 2y, you will leave us 2 because of variable y. Implicitly, we have to multiply with dy dx. Then continue equal, differentiate constant. Differentiate constant will leave us 0. plus. So this is one term only. This is not product rule because this is constant. We have to refer to our x in dy dx. So we only need to differentiate dy dx. Differentiate dy dx here will become 4 d2y dx squared. So this 4 is a coefficient for this dy dx. So this is not a product rule. So product rules means in front here in function of x, at the back here also function of x. Then we will apply our product rule like this. This is variable y. In front here we have a function of y which is linear. At the back here we have a function of y dy dx. So that will be product rule. So this one is not. Okay, we just directly differentiate on dy dx to get d2y dx squared. Okay, so after we obtain our second derivative test, second derivative, and then first derivative, we're going to find out its value. Okay, so our purpose here, when it give us a point here, means they ask us to find out that value. So if you want to find out this d2y dx squared, so look at our d2y dx squared here. I want to find out this d2y dx squared. I want to find out this d2y dx squared. So what value should I substitute in order to find out the result? So we must have a y. Yes, we already have a y from the coordinate here. Y equals to 0. Then we must have the value of dy dx. We have to obtain our dy dx value, then only we can substitute it completely. So therefore, now we're going to find out our dy dx value first before we going to find our d2y dx square value. So we want to find our first derivative value, we'll use the equation from our first derivative. We substitute x equals to 5, y equals to 0 in order to find out the value of dy dx. So it will be 2 times 5, and then 2 times 0, then everything gets 0. 2 times 0 here, everything we get 0. Equals to 5 plus 4 dy dx. So here we have 10. So 4 dy dx will equals to 5 dy dx equals to 5 over 4. Finally, we get everything complete. Okay, we get everything, our value, everything complete. So we're going to substitute where y is equal to 0, and then dy dx equals to 5 over 4, so that we can obtain our second derivative. So at the same time, here 2 times 0, everything becomes 0. Then 5 dy dx 5 over 4 times 2 times 5 over 4. Then this is 0, this is okay. So we evaluate this. Press your calculator, we evaluate this. So we evaluate this, we'll get 41 over 8. Then finally move the 4 to the right hand side, become 41 over 32.